Alrighty, ladies and gentlemen, hello and welcome to the first section of Chapter 7, which is on triangles, and 99.9% of the time with what we deal with in this chapter is going to be non-right triangles. So everything we've learned up to this point has held true for right triangles, okay, where we could use the SOHCAHTOA, trig ratios. Okay, this chapter we're going to talk about how can we find angle measures and side lengths when they are not right triangles. Okay, so the first thing that we're going to learn about is what we call the law of sines, and that works for any case of triangle, okay, whether it's right or not. So the law of sines tells us that the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. Okay, so really all this is saying is if I think about this angle A, if I do that sine of A, I should do capital A, sine of that angle over A, I can set it equal to another angle, so I'll switch it up, another angle, and its opposite side, so I can say that's equal to the sine of B over little b. Or you can also do it on the bottom way, because if two fractions are equal, the reciprocals are also equal, okay? So you guys are going to find that 7.1 is probably the easiest part of this chapter. So let's dive in and take a look at what we got to do. So it says use the law of sines to solve the triangle. Okay, so the three things that we've got to find are angle C, side A, and side C. The easiest one to find here would be find angle C by taking 180 minus 80. Not 80, minus 100. I was doing math in my head. 180 minus 100 is equal to 80 degrees. Okay, so that there is 80 degrees. Okay, the next one I want to do is find side A. So I'm looking for this one right here. Now, what I'm going to do is say that the sine of 70, because that's the angle opposite, sine of 70 over A, is equal to, now I've got to figure out, because I've already got one unknown, I've got to find an angle and its side length that I could use where I know both of them. Now notice that I know that this angle and its opposite side, so I can set it equal to the sine of 30 over 8. So now we're going to do that dirty thing where we cross multiply. So I'm going to get 8 sine 70 is equal to a sine 30. To get a by itself, I'm going to get a is equal to 8 sine 70 divided by sine of 30. Now, at home, you guys should try and type this into your calculator. It says to round to the nearest whole number, and that is going to give us a is equal to approximately, if we round, it would be 15 centimeters. Okay, so there's a. Now, whenever possible, we never want to use rounded values. You guys are going to see later in this chapter where sometimes it's unavoidable. But on this one, we don't have to worry about using that rounded value because I can still use those two things that I knew right off the bat. Okay? So I'm going to start by saying on this one, if I want to find side C, I'm going to start with what I know. Sine of 30 over 8 is equal to, now I'm going to talk about part C here. So finding side C, I'm going to say the sine of 80 over C. Now, we did have to use something that wasn't known here, but that's not a rounded value, so that's not a huge deal here. Okay, it's much better to do that rather than go sine of 70 over that rounded value of 15. Okay, so we're going to solve this. Eventually, you guys, I'm going to skip this step of cross multiplying and just jump right to the answer. So this is C sine 30 is equal to 8 sine 80. If I get C by itself, that gives me 8 sine 80, all divided by sine 30, which should give me C as approximately 16 centimeters. Okay, so that's approximately 16 centimeters. Now here's a good thing to always check. Remember, the angle that is largest, the side opposite should be the biggest. Checks out here. Okay, so we're in good shape there. Okay, example 2. Find the distance the shot put was thrown. So we're looking at, this is where you start. Someone in the observation booth up here is looking from where you started to where you ended was an angle of 5.7 degrees, and I gotta find that value of x. Now notice I added y here just so that we get one more one to practice, because I've only got one more example and I don't know that I even really want to do that one. Okay, so if I were to do law of sines here, I could say, because I know this angle and its opposite, I can say sine of 85.3 over 562 is equal to the sine of, what is it, 5.7? Yep, so sine of 5.7. Sine of 5.7 over x. The goal is to get x by itself. So I'm going to skip this step, and this is going to be x is equal to, this is just coming from cross multiplying, guys, 562 sine 5.7, all divided by sine 85.3. Okay, if you type that in, what do we want to go to the nearest tenth of a foot? That one should come out as approximately 56.0 feet. Okay, so there's that. You guys try and set this one up and figure out why for me if you can. So go ahead and pause that video, and then once you finish, go ahead and restart it. I'm just going to keep working, so see if you did it the same way as I did when we come back. So in order to find y, I've got to know this angle opposite. That one would be 89 degrees if I take 180 minus 5.7 minus 85.3. So I could say sine of 89 is equal, or no, sine of 89 over y, sorry, sine of 89 over y is equal to, same thing as the last one, sine of 85.3 over 562. So this would give me, what, 562 sine 89 is equal to y sine 85, nope, I messed up. 562 sine 89 over sine of 85.3 is equal to y, and when you guys type that in, you should get approximately, what did I get? 563.8 feet, which seems reasonable because if this one is the largest angle, side opposite should also be the largest. Okay. This next one here, I don't want to do this problem because every year we have arguments about this, me and the physics kids, and to be honest, I'm not 100% sure on this, so rather than try and confuse us, we're going to cross this out, but I do want you guys to draw one triangle, just so I can kind of talk about this one. So if I gave you, let me think here, if I gave you, we'll call this 70 degrees, we'll call this 92 feet, and I'm going to call this, actually no, we don't have to worry about that. We'll do this in the second video, okay? So, your homework, right here, page 335 through 337, 1 through 19 odd, 25 through 27, or 25, 27, and 31. Now, the next lesson is on more of the law of sines, but we're going to deal with the thing that I was just drawing here.